All right, moving on to 3-7. It's going to be very similar to what we just previously did. We're going to use the distributive property as well as the associative property, commutative property, and now we're adding into the to our list of operations the identity property. And we're going to use that to simplify and combine like terms to make our algebraic expression as simplified as we can. Okay? All right, so this is 3-7. 3-7. Simplify algebraic expressions. Our goal is to, I can combine like terms in algebraic expressions. I can combine like terms in algebraic expressions. Ah, where have you seen terms from? Where have you heard that? Oh, it's when we were doing algebraic expressions before and we had to circle the terms, and what was separating the terms were addition signs and subtraction signs. So guess what we're dealing with here? Addition and subtraction. Now, that doesn't mean that we won't have any multiplication or division. It's just we're going to have a lot of addition and subtraction. And remember, our coefficients are 2 times x or whatever that is. That's multiplication, but it doesn't. That's part of a term. All right, so let's get into our new identity property here. Identity property. Now, the properties themselves aren't difficult. They're just, you've got 4 of them now that you're using. And it's what you need to do is, the difficult part is separating them and understanding which one is which. All right, just like the previous ones, they represent 2 operations. These 2 are addition and multiplication. Multiplication. The first one is, they're really simple. A plus 0 is equal to A. Oh, yeah. 1 plus 0 is 1. 4 plus 0 is 4. That's what it's saying. The other thing that it's saying is that if I just had A, I can break that up into... oh, God. Yeah, I'm sorry. A plus 0 is equal to A. A can be broken up into 0 plus A. So that means, okay, give me a second. Harrison's in the potty, give me a second. You okay, boy? No? All right, do you copy everything? All right, just wipe up and then you can go watch YouTube. Sorry, I'm back. All right, so what that would look like over here would be, let's just say 5 plus 0 is equal to 5. Yeah, well, no spla. But when we have just 5 here, we can then take that and do, well, 0 plus 5. And that doesn't quite make any sense right now, but you'll see when we start to use the properties. Like, oh, okay, that's what he's talking about. Okay, cool. The next one is doing the multiplication one. So let's say we have A times 1. Well, that's going to be equal to A. For example, 4 times 1 is 4. Or 3 times 1 is 3. A million times 1 is a million. So that's what we use when we're doing the oh gosh, I can't remember. Oh, when we're isolating when we're isolating the variables and getting rid of a coefficient or whatever, anything times 1 is itself. So a times 1 is just, we can just write it down as a. Now the reverse of that is we could, if we needed to have a number there, well, we know that 1 times a is a. And this will really come in handy later. You'll see when we do our examples. So what that really is saying is 5 times 1 is equal to 5, and then 1 times 5, or 5 can be written as 1 times 5. That's the identity property. So now we're going to do some examples, and we're going to use all these different properties, okay? And we're going to combine like terms. And like terms are just terms that are similar. Maybe they have the same variable, right? Or they don't have, or they're alike because they don't have a variable. And we're going to combine them so that we don't have this super long algebraic expression. We can shorten it down, simplify it. So here is an example. We'll start off real simple. X plus X plus X. Well, these are all alike because they have the same variable. So what we're going to do here is use the identity property of multiplication. And I'll show you what that looks like. That's this right up here where it says a can be written as 1 times a. Well, I can rewrite all of these x's as 1x, 1 times x. 1 times x is the same thing as just saying x. But you're going to see why that might be helpful when you've got to combine these things. So this is using the identity property. I'm just going to put IP of m. Identity property of multiplication. Now I'm going to use the distributive property and figure out what factor all three of these have. 1, 1, and 1. Well, they have 1 in common, right? So I'm going to take out this 1 from here, here, and here and add them all together. Oops, that should be a 1. I'm sorry. They all have x in common. So I'm going to take out the x and just leave the 1s there. So I took out the x. I'm going to add these 1s together. I get 3, and then bring your x down. So x plus x plus x is 3x, although I'm sure you thought that already, right? 3x's all added together is 3x. Okay, well, let's use those same properties now with the expression 2y minus y. So 2y and y are like terms. I need to combine them. So I don't have an operation in there. I just have, I don't have an operation of subtraction. I just have multiplication. So I've got 2y minus y. What this really is 2y minus 1y. And then I can use the distributive property to take the y out here. So then I'm left with 2 minus 1 y. And then 2 minus 1 is just 1 y or y. Okay, so it's one of those things where you have to sort of grasp that the easiest way is not the way that we're doing it right now, right? The easiest way would just be like, oh, x plus x plus x, that's 3x. 2y minus 1y is 1y, duh. But I'm going through all the motions to use identity property because, and distributive property, and commutative property, and associative property, because you will be using those in 7th grade. And I'm just getting you familiar with the terms and getting you familiar with using them, because when 7th grade comes along or 8th grade comes along, you are now prepared to do more difficult problems, hopefully. All right, let's do the next one. We have n plus 2/3 n, plus 2n plus 4. All right, so now we've got to identify the like terms and rewrite them using the associative property to make it easier for us. Okay, so what do we have in oh, it's already written. I'm sorry. All the n's are next to each other. So we're looking at these numbers here, n plus 2/3 n plus 2n. And what that is really 1n plus 2/3 n plus 2n, and then of course plus 4. And now I'm going to take out the n here. When we have 1 plus 2/3 plus 2 times n plus 4. And then this looks really crazy, like we're gonna have to turn these into fractions or not. But no, these are whole numbers. So really what we're doing is 1 plus 2 is 3, and then the 2/3 there, times n plus 4. And that's our answer. So it looks more complicated than it actually is. We're just seeing that, oh, these all have n's in them. Okay, cool. I'm going to pull that n out. There it is. And I'm going to just look at the coefficient here. I'm going to add all the coefficients up and then put the n right next to it at the end. And then, of course, this 4 just comes along for the ride. He doesn't actually get combined with anything else. Or she, who knows. Let's with these ones, it just takes a lot of practice. I'm going to cherry pick here and pick some ones that I feel like that I think you'll run across and have some struggles with. And you know those are going to be the the fraction ones and the decimal ones. So here we go. Some practice problems. Let me get some paper. Where you at, paper? There we go. That was number 3, so let's move on to number 4. All right, let's do another fraction one. Now, again, because they're teaching you these new properties, they're not really focused in on if you can do some really difficult fraction problems. They want to see that you're doing the problems correctly. So even though these are fractions, they're not terribly difficult. So we got 3/4 z to the 3rd plus 4. Oh, that boy was in the potty for a long time. Hope he's okay. 1/4 z to the 3rd. So my first step is I need to figure out which ones are like terms. Oh, okay, well, we've got 3/4 z to the 3rd, and we have 1/4 z to the 3rd. Those are like terms. So I'm going to look at those first. So I'm going to rewrite this so that they're next to each other. I'm going to do 3/4 z to the 3rd minus 1/4 z to the 3rd, and then plus 4. And now I'm going to use the distributive property to take out that z to the 3rd so that I'm just looking at the fractions now. And the z to the 3rd is not in my way. So now I'm looking at 3/4 minus 1/4. Well, lucky for me, they both have the same denominator, and I can just take away the 3 and the 1. So 3 take away 1 is 2/4, or 1/2, z to the 3rd plus 4. So there's my answer. If you wanted to reduce it, you could. 1/2 z 3rd plus 4. And there's my answer. So don't get freaked out by the fractions. All you need to do is remember that you need to find the like terms, z to the 3rd, and then use the distributive property to take out that z to the 3rd, so all you're dealing with is the coefficient. Subtract or add or whatever you need to do to those, and then bring it down. Okay, number 5. Let's do a decimal one. It's the same concept, but now you're just using decimals. So we have 4 2/10 n plus 5 plus, oh, no, it's a minus, minus 3 2/10 n. So again, I'm going to get my like terms next to each other, including that operation that goes with it. So I'm going to take that 4 2/10 n, I'm going to minus 3 2/10 n, and I'm going to add the 5. Again, they're giving you decimals, they're giving you fractions, but my goodness, they're giving you easy ones, so that's nice. If you can't see it in your head, I'm going to do it over here off to the side. Line up my decimals when I'm adding. 2 minus 2 is 0. Put my decimal. 4 minus 3 is 1. Ah, it's just 1. Oops, got ahead of myself. Using distributive property. So that's what this is over here. 4 2/10 minus 3 2/10. Subtract those, I get 1 times n. Another way of just saying that is just n, using the identity property. So now I have n plus 5 is my answer. So this long algebraic expression here is the same thing as saying n plus 5. You can see why you wanted to break it down. Would you rather do n plus 5 or 4 2/10 n plus 5 minus 3 2/10 n? I'd rather do n plus 5. All right, 6. All right, let's get into some ones that look a little bit tricky. This one's not tricky, but I feel like I need to address it because whenever you guys see an exponent to the 3rd or 4th or 5th power, your brains start going haywire and you start acting crazy. So the like terms are q to the 5th power. And what that really is 1 q to the 5th power plus 1 q to the 5th power plus 1 q to the 5th power. If I use distributive property here, I get 1 plus 1 plus 1 times q to the 5th power. Well, 1 plus 1 plus 1 is just 3. And then that's the coefficient. Your variable is q to the 5th power. And that's my answer. So that one looks harder than it actually is. It's not that difficult. Again, I'm moving kind of fast here. Pause in between problems, write down whatever you need to write down. Yeah. So I only get so long before, the baby wakes up or gets loud or Harrison needs my help. So I'm moving kind of quickly through it. All right, let's do this long one here. 3x plus 1/4 plus, 2 variables. We got x and we got y. Plus 1/4 plus 7x. Oh, does it ever end? Minus y. Ooh, look at that bad boy. Well, I'm not scared because all I have to do is find the like terms and combine them. So let's start with the x's first. I've got 3x and I've got 7x. So I'm going to put those bad boys right next to each other. 3x plus 7x. Then I'm going to do my other variable next. I'm going to use the y's. So I got 2y plus 2y, and we have minus y. And then I've got plus 1/4 plus 1/4. There we go. Now I'm going to start combining them using distributive property. This would be 3 plus 7 in parentheses, with the x out. I'm just going to move right into the next one. I got 2 minus 1 in parentheses with the y right next to it. And then I'm just going to go ahead and add these up already. This is 1 plus 1 is 2, and then my denominator is just 4. All right, so then we have 7 plus 3 is 10. That's 10x. 2 minus 1 is 1y, or just y. And then I'm going to simplify this bad boy down to 1/2. I'm just going to divide out of 2, right? Divide by 2, divide by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And then there's my answer. 10x plus y plus 1/2. Let's do one more, and then we'll be done. Yeah, this should be fine. Should be enough room. All right, 8. 1.5, I'm using decimals here, x squared plus 4.5 plus 6z minus 3/10 minus 3z plus z, z squared. Sorry, this was a z up ahead in the first one, z squared, not x squared. This one's long, but again, I'm looking for the like terms, and I see here I've got a z squared and I've got a z squared. So I'm going to combine those. I'm going to put 1.5 z squared plus z squared. The next one I'm going to see, I see here is plus 6z minus 3z, and then my whole numbers here, or my decimals I should say, plus 4.5, ooh, I'm running out of room here, minus 3/10. Oy, oy, oy. Long. All right, let's start with the z squareds. This is 1.5 plus 1 z squared using distributive property. Using distributive property here, I'm going to take out, yeah, I'm going to take out the 6 minus 3z. What I'm doing is I'm taking out the variable and putting the coefficients in the parentheses. And then I'm just subtracting this. 4.5 minus 3/10 would be 4 2/10. It'd be funny if I like made tons of mistakes on my video and I like can't tell, because in classroom I make mistakes and then somebody catches me. You will let me know in the comments, right? 1.5 plus 1 is 2.5. Z squared. 6 minus 3 is 3, and then z, and then just 4 2/10. And there you have it. We've got a simplified algebraic expression. I'll be posting the virtual nerd videos on Pearson. Take a look at those. Hopefully you guys are doing okay. If you don't, ask questions, please. We'll try to get a... I like doing... I think I'll like doing... I'm making this video before I've ever done a conference on Meet, so I think I'm gonna enjoy doing like a small group rather than like a group of 31. So if you want to do the small group tutoring for this in Meet, let me know. If you're still like struggling, use the tutorials, use practice problems, use YouTube, Khan Academy, Virtual Nerd on Pearson. All right, good luck. Bye.